Hello students, welcome back. Let's go to problem 2. According to a September 2008 Poland report done by Pew Internet, 62% of employed adults use the internet or email on their jobs. By the way, this problem came from this textbook, and that certifies that this problem is pretty much appropriate for our purpose here. It's not outrageous, it's a textbook level problem. You should be able to do this. Okay, let's go to the problem. Use the normal approximation to estimate the probability that more than 170 out of 250 employed adults use the internet or email on their jobs. You have to use the normal approximation, so let's begin from the picture, the normal picture. Here's the outline, but the next question is, what's the center? Good question, what's the center? It's tempting to go with 62% because, after all, that's what the Pew Internet poll data came. But then again, the problem is asking you about probability for more than 170 people. Now, how do you compare 62% and 170 people? You can't. One is proportion, the other is counting. We are talking about two completely different quantities here. You have to make them into same unit, same type of quantity so that you can compare. One way to do that is to change the 62% into counting. What do you mean by that? We have 250 employed adults. What is 62% of 250? It's 155. See the computation here? 0.62 times 250. So 62% of 250 total is 125, and that goes to the center. 155 goes to the center. Another way is to change this one into ratio, change this one into percentage, and then compare that with 62%. And by the way, that's the second problem down here. Let's come back to this. Usually it is better to go toward the goal. See? Instead of trying to change the goal to your liking, it's better to move toward the goal. And our goal here is more than 170. So it's better to change this one toward the goal. And we just did it, 155 people. So that goes to the center. And we ended up with this picture. 155. And then 170, and probability for more than 170. This one right here, shaded to the right. Does it make sense? So how do we do that? Well, z-score is n minus center over SD. And then in this case, that's going to be approximately equal to 170 minus 155 over standard deviation. What is the standard deviation, by the way? Did this problem give you that? Let's go to the problem. It didn't give you anything. It did not explicitly give you the standard deviation. How do you get it? This is what you can hold on to. This formula, sigma equals to square root of n p1 minus p. This one, the center, we already used it up, you see. That's how we used. We got the center. And the standard deviation follows the second formula here. This formula here is not that important, as a matter of fact. It's just for this type of problem, and it's not going to come back very often, but keep it somewhere in your formula sheet so that you can be prepared for the exam. Anyway, here's the computation. Square root of 250 times p-value 0.62 minus times, 1 minus 0.62, which is 0.38. And that's the computation. And that's your standard that's the standard deviation. That's going to go down there. So we can calculate all this using your calculator. I have Mathematica here with me, so let me just save my time. Here's a computation, and you can stop this playback and you can go ahead with computation with your calculator. And you're going to get this kind of number. And that is approximately equal to 1.95. Yeah, you have to take 2 decimal digits in order to look up the z-table. So we need to do it this way. And then let's look up the z-table. And what comes from there is going to be the probability, you see. The probability that x is less than 170, our goal, is approximately equal to probability that, no, actually is greater, more than 170. So z-score is greater than 1.95. And that's something we'll have to calculate. Make sense? So this computation we did, this z-score, and that's associated to this end of 170. So the probability of more than 170 means probability of z-value greater than 1.95, approximately speaking, of course. And let's look up the table and find out. Ready? Okay, let's look up 1.95. 1.9 is here. Go to the 5th column, 0.9744. 0.9744. So is that the answer? Looks good. Is that the answer? No, not really. I mean, look at this shading here, the red part, more than 170. This part doesn't look like 97.4%. This should be. This blue part must be 97.4%. We need 1 minus of that. And that computation is 0.0256. So that's the probability you're looking for. If you prefer in percentages, 2.56% approximately speaking. This is what you got from the normal approximation, and I'll take this kind of answer as full credit. There may be some other kind of computation regarding these rounding errors and so on. For example, here's one, and this time I did not use the normal table. I used computer algebra system for a little bit more precise computation and ended up with something like this. And if you're really good at your calculator, it is possible to calculate all those z-values and probabilities using your calculator if you have TI 80 series or higher or equivalent. In any case, you're getting about 2.53% if you do it a little bit more precisely. And then if you use crude z-table method, then 2.56%. Either way, I'm going to take it as full credit. Now, there may be some students who are questioning the validity of this 170. I hear you. I'll come back and discuss that in an optional video because that's a bit of an advanced issue. For now, let's keep it at that and move on to the next problem. Use a normal approximation to estimate the probability that more than 68% of 250 employed adults use internet or email on their jobs. This time, we have 62% versus 68%. So it's easier this way. You can compare directly. So this time, I'm not asking you this problem about drawing a picture. I mean, what's the center? And just draw the picture. 62% here, 68% here, more than 68% come there. By the way, if you're wondering where the 68% is coming into play, it's 170 over 250. So problem number 2 should give you the same answer as problem 2.1, as a matter of fact, because we are dealing with basically same numbers, same setting, just written in proportion. Now, in this case, The center is the observed proportion, P, and the standard deviation follows a little bit different formula. Square root of P1 minus P over N. And this formula, by the way, is extremely important. Previous formula is not that important for our purpose, but this one is. We're going to come back over and over again to this one. And each time we come back, we're going to get closer and closer to the real-life application problems. This one, yes, it came from real-life application in a sense that it came from Pew Internet poll results, but it's a bit artificial. 250 people selected, and you could easily measure those, but why are we doing this? Anyway, this is rather artificial, but in any case, it's a preparation of what's to come. And please remember this formula, and here's the computation of that. 0.62, 1 minus 0.62, which is 0.38, divided by 250, and take the square root of that. That is the standard deviation. And if you calculate all that, z-score is n minus center over SD. In this case, it is 0.68 minus 0.62 divided by the standard deviation of, let's see, this computation. And that's what you have to do. You can use a calculator to do that, but let me use Mathematica now that I have it here. And not surprisingly, of course, I got the same computation as before, which is approximately equal to 1.95, and the same conclusion as before. Oh, I erased it. Okay, I'll have to do this again then. So basically the probability of having more than 0.68% or 68% was greater than 0.68 is approximately equal to probability of z-score greater than 1.95, approximately speaking, and that's approximately equal to, looking at 1.95 from the z table, and 0.9744, and that is approximately equal to 0.0256 or 2.56%. By the way, here is a little bit more accurate computation using the computer algebra system. Okay, instead of z-table, I use more decimal digits, and I use computer to calculate all those, and I got a little bit better approximation, 0.0253 something, so 2.53%. It's a little bit better approximation compared with these. The real value, as a matter of fact, is going to be about 0.0207 something. Okay, basically we went through one problem because 170 out of 250 is the same as 68% of 250. So basically these two problems are the same, but written in two different viewpoints, and then we approached in two different angles. One method we used this SD formula, which is not that important. It's used only for this kind of example. And the other method we used this formula, which is extremely important and has a lot of other applications as well. The second example is more important, and please keep that in your mind.